Hello everybody. So today's video is going to be a little bit different from my previous videos. We're actually going to build a Sudoku game. This is something that I've enjoyed for a long time, playing Sudoku games whenever I want to turn off my brain and just relax. And just a couple of hours ago, as I was playing a Sudoku game in the newspaper, I actually realized I wanted a app that enabled me to copy over the physical Sudoku game into a website, web app, whatever, where I can actually do the game and perform errors, like actually make a mistake without having to erase it using like a regular pen or something. I wanted to be able to do it on my phone or my computer. So I found that these apps already exist, obviously, but I wanted to do this as a fun challenge, and I figured it'd be a fun video as well. So what I have in front of me is the base setup that I created before this video in order to save some time so that you guys don't have to look at me setting up yet another React app, because most of you have probably done that 1,000 times as well as me. So this is a basic Vite setup with React. We're using a Tailwind setup as well, using Shadcn for basic components. Really just a button actually right now. And I've built the UI based on a simple design that I created in Figma. So it looks just like any other Sudoku. So you have the squares within squares. So you have these groups, the 9 groups, which has 9 squares. Short version of explaining of Sudoku if you don't know or if you haven't played. You need to put in the numbers between 1 and 9 in each of these squares, and they can never occur the same time within one square. Neither can they occur more than once in a vertical or a horizontal line. So the number 1 can never again occur in this vertical line nor in this horizontal line. That's the game. Usually when you start the game, you have a set numbers that are placed out into the board, and then you have to complete it based on the numbers that are already in place. But the first major purpose or goal of this is that we want to be able to create a base setup for a game. So I want to be able to take a Sudoku game, put that into the app, and then save that so that I can actually start that game so that you can create these games, which is a fun little challenge. So let's look at the code setup. First of all, if you want to code along with me, I've set up this base setup in in GitHub. So you can just go to the URL. It's going to be in the description as well, and where you can find the whole setup, just exactly the same that I have right now in the beginning of the video. We're going to quickly look over the code. So as I said, we have Vite, React, Tailwind, and Shadcn. So we got everything set up, tsconfig, we have Vite config, Tailwind, post.css, as well as components for our Shadcn. If we look at the main app here, this is going to be the game, sort of the component that takes care of all the game logic. So it takes care of the game state. It has the square that you've selected, the number key that's selected. I'm going to show you more exactly what this means. So this is going to be the core component that handles all the logic for a game. And then, of course, there's just the main. We have some index CSS, just base stuff. We have our types here. We just have a game state and a selected square for now. Nothing fancy there. And if we take a look at the subcomponents, we have 4 different subcomponents that I built. The UI, of course, is the Shadcn button. I did some minor tweaks just to adapt it a little bit more to my liking, but it's basically the same thing as Shadcn base button. First of all, we have the actual game board. Now the game board is what you see in the UI here. It's this. You can actually start up the app. I use PNPM, by the way. And we start up the app. You can see here that this is actually our board, and now for some reason the actual height of these squares are not correct. Something is wrong. Oh yeah. I think I messed up it's because I formatted the initial state here. We have line breaks for these. This was just to visualize it better. I think that's why, yeah, for some reason it adds another line break there. Interesting. That shouldn't happen, honestly, but for some reason it does. That's an interesting thing. That's actually really, really interesting. let me get back to that. So let's go back to going over the code base. This is the actual UI. So the game board is the whole thing here, except for the number keyboard down here. The game board contains the 9 number groups. These are the big squares here. So these 9 squares, these 9 squares, all of them are individual groups called a number group. Now the number group component, of course, just contains all the number squares. So the game board takes in the state, loops over the state as each group. So if you look at the app state here, you can see that this is one group. So it loops over all of these to create a number group for each of them. And then the number group loops over all of the numbers within its group. So currently it's null for all of them. So it loops over them and uses the number square to populate up the individual squares. The individual squares then populates the number as the contents. Yeah, exactly. And then we have a simple span that just shows whenever the square is selected. So when you click on this square, we propagate that up to the number group, which in itself propagates that up into the game board, which then takes both of the, first of all, the number group just pushes up the square, the index of the square up to the game board. The game board then takes that square, adds the number of the group, the index of the group, pushes that up into the app that can then take that number index and the group index to set a state for which square is selected. That way we know which group and which number is selected. So when you click, you can see that you have a little square that shows which one of these squares is selected. You can also toggle by clicking again. That's the basics of the actual game board. And then you have a number keyboard. It's a super simple loop of all the numbers between 1 and 9, and then just creates the button from Shadcn button. And then you're able to click on it in order to tell that, okay, I want to populate up number 1, number 2, number 3, number 4, blah, blah, blah. Also, you can toggle these on and off. So the point of that UI is that I want to be able to say, okay, in this square, I want to populate number 3. And I want to populate number 3 there, let's say there, and there, for example. That's the point of the UI. And the point is also that it's supposed to work somewhat easily for mobile phones. So these squares are quite small. Initially, these were for the iPhone 13 mini, so that it works in a smaller view like this. I might actually move these down to have like a 3x3 format. We'll see. So this is just a base setup. So I hope that sort of explains the base setup I have here. The first thing I want to do quickly before we get going is just investigate why this causes the UI to go like this. I might suspect that it has anything to do with this. No, because if we remove that, nothing really happens there. So oddly enough, it's something to do with the fact that you have line break for each of these. But it might simply be because it adds another, I don't know, it's really weird. Let's just keep that as it is for now, and then just yeah, right. Let's just commit that up as well. So Sudoku. I apologize. My poor keyboard skills. Okay, so now we've reset that so that you guys can follow along. So since we have these two states, the selected square and the selected number key, now we can actually use that to change the game state and populate up numbers at the specific index and the specific group. So we can see here by handle number key click, if we have, in the case that it's a selected number, in this case, we can check if there's a selected square. If there's a selected square, we want to populate that number on that specific selected square. That's the idea, at least. So here, if selected square, we don't want to handle a number click. We know that the number index is something and the group index is something. So what we want to do is using these, we want to go into the game state and change it. So set game state. Then we have previous states. Let's see what it does. So let's grab the new, set a new state, selected square, group index, selected number index is equal to that number. Yeah, I think that is that's reasonable. Let's see what happens. So if we go into click number 1, sorry, I actually changed the other way around. Sorry. So if I click number 2, it should populate number 2, 3. Yeah, nice. So same thing here. Number 1, nice. So that works. That's cool. Next thing we want to do is do the same thing here for set selected square. So if selected number key, we want to do the same thing. Nice. I appreciate the fact that cursor does this automatically for us pretty easily. So let's say we want to add a number 1 there, there, and there. Great, nice, that works pretty well. Let's see, if we click number 1 in this case, maybe we want this to clear out this thing. I think that would be neat. So if you click number 1 in this case, I'd say if I click number 1, when I'm on number 1, I should clear it out. So if selected square here. So when you click number 1 and you are have a selected square, we want to check that that selected square number if it's not that number, then we want to set it to that number. Otherwise, we can reset it. So let's say we set number 1. That didn't work. Okay, interesting. What am I missing? There's no errors. What am I missing? This should reset it. Yeah. So if the new state of selected square group index, selected number index is equal to null, we want to set it to that. Okay, so we can just toggle it for now. Interesting. Interesting. Okay, so let's log. No? Let's just log that for now and see what happens. Null, now it's 1. Oh, is it because the state changes? Is that why? Oh, I see. I see, so we might have to do this as a callback then. I wonder if that's gonna work though. No, it's gonna trigger it anyway. Actually, what did I select that square? We should actually have game state in there as well. It shouldn't actually log the new state change in that way, but I guess that's a part of how React works. maybe we can skip this for now. Maybe I'm too tired to remember why this is. This obviously it has something to do with the state and how React handles states, but this works for now. I think this is fine. We should add a clear button, I think, like right next to this point here. Let's add a icon library. Sampler icons React. Sampler / icons React. Let's add that little clear button to our number keyboard here. Let's import icon trash from let's check how that looks. Oh, sorry. Closed it down. Let's see. Why is it loading forever? Oh, there we go. Okay. Let's see. Can we change the color? Why is it so slow? Is it because of the icons? Jesus. Let's do class name. Text red 500. I think that should be good enough. Yeah, that looks good. So let's see. When you click this, I want to clear out whatever is in a specific square. So when I click this, I want to clear out the square. So let's say on click, and we have a on clear click. And in our app, we have on clear click and a clear click. That's not what we want to do. So let's see, if selected square, set the game state, and then clear that out. That's what we want to do. Cool. I wonder if it's actually Tableau that makes the app actually load so slow. It might be, interestingly enough. So let's say 9, and then we click clear, and we clear it out. Nice. We might have to work on this UI a little bit more, like interaction and stuff later on. But let's move on to how we can actually validate the game state. So what we know is that when you populate up like a number 1 here, we know that that is the only number of the only number 1 can exist inside of the square, as well as vertically and horizontally on this line. So what we want to do is validate the state whenever it's changed, to say that, okay, well, now you've changed this, and let's make sure that each number can only occur once in the ways that we know, and if it does occur more than once, that we can give some kind of error to the user. In our app, we can have like a use effect on our game state. So whenever the game state changes, we can check that the game state is actually valid. And the thing is, we need to know the last change of the state that was made as well. So we need to keep a track of the history of the changes. That way we can also revert back our changes with some kind of go back button or something like that, so you can revert something. So let's start by creating a state called history, action history. So action history. Now each action has to have some kind of information. So what the action is could be like an add a number, like, or you can revert removing a number, because now we have the trash icon here. You can actually clear up something that you added. So the action history needs to contain everything that you do. So let's look at what that type would contain. So let's say type action history is not a game state. It actually it's export type action. Type could be, let's see, add number, remove number. That should be the two different actions that you can perform. Yeah, add and remove number. And the payload would be the group index, the number index, and the number. I think so. So is that really what we want to do, or should we just keep track of the game state in an array so that you can go back to the previous game state? Is that easier? Because that way, the new game state, whenever the game state changes, we can just add it to our history. That way we don't have to look at each action and then remove something in order to change the state. The state is the only thing that the only thing that matters is the state. I also apologize for doing this sort of ad hoc. I haven't really built a game in years, so this is somewhat of a learning opportunity for me as well. I think maybe let's try and keep track of the state history instead. Game state history. That's the only thing I really care about. But oh yeah, we still want to know what the action was, because if we can look at the action, we can validate that this action is what caused the error. That's why we want to keep track of the action, right? That's true. That's very true. Okay, yeah, so we don't want to have the game history. I think we need to have the action. Set action history. So let's take this back. We have the action type, the payload. Let's see. The action is also add and remove, so we can say like which square is equal to, yeah, we can say selected square, but actually no, it's actually going to be, let's say export type square equals this. Exactly. So now we don't have a nullable. The square is always also, it has to always be something. So new value is equal to number or null. Previous value is number or null. So that way, when you add a number, you know the previous value was null. The new value will be the number, and the opposite is true for removing numbers. So that way you can revert the action much more easily. Okay. So let's see. In this case, we need to add, in this case, we need to add to the history. And in this case, we also need to add to the history and this as well, right? So let's say add action to history. We add a number, the square is that, the new value is selected number, key, previous value is this formatted much better. Previous state, group index, number index. I think this should work. We don't want this to be, let's do it this way. Oh, Jesus, I don't know how that happened. Let's add it there. Actually, I think previous state is not going to change. Sorry, that's cursor was right. I think this should be correct. This should be fine. So let's see. Let's copy this down here. And we have, this is the group index. It's the number index. Yeah, of course you can do that, obviously. And the number is going to be the new value. The previous state is going to be this. Yep, that was good. So now we populate up the history pretty well. Then let's do the same thing over here. Remove number for the selected square with the value of null, and then previous value is this. Okay, that looks good. So as we do this, let's just use effects and see what happens when we add stuff to our history. I really don't like that it's loading so slowly. It's really, really bad. Let's see what happens if we go ahead and remove the icon trash from Tabular. The input, the import, let's just do delete here. See what happens if we do that. For some reason, Tabular makes things really slow. I really don't like that. Let's just do this manually for now, because you can do, what you can do is just do this trash. Oh, really? There it is. Interesting. Here's the SVG. So let's just add that as our own icon, and let's just remove Tabular for now. For some reason, it's really slow. Let's see. Components. Icon trash. Icon trash. No TSX. Like so. Let's see, current color, thank you. So that does it for us. Let's see, let's import trash. Let's add it there, and it should look the way it did before. Nice, cool. Now we don't have to care about that. Of course, we need to go into Tabular or the actual icon and fix up our here. To care about those, fix those up, thank you, cursor. Nice, so now that works. So now you can see the action state here is actually empty. So let's go ahead and change it to 1. Let's see what happens. We can see that it happens twice, and it's probably because the state changes twice. Let's see here. Previous state. Am I sending the wrong? Oh, I have the wrong typing here. There we go. It's the whole use state debacle here that is causing me some issues. it adds the number twice, which is weird. Might be because of the set games that we do it within the game state, which is not something we should do, probably. Okay, so we need to grab the previous value of the one that we are actually trying to change, right? So this feels really ugly. Not sure if this is gonna work. Oh, it did. Great. Awesome. So now every action is added to a history. You can see that we added a number to our square 0, 0 with a value of 1. Previous value was null. Then we can actually remove that. Did we remove the click on the button? No, we did not. On clear click. Oh yeah. Okay, sorry. Yeah, that explains it. So now we have a couple of extra here. We can see that. Okay, so we need to fix up some things. We can see that when you click this again, if you have selected, we've selected number 1. For some reason, that doesn't happen again. Interesting. There's a couple of bugs here. All right, cool. First of all, let's put this down so it's easier to look over. Next, let's see. Number keyboard, we have on number click, handle number key click. Right here, right. If the selected number key is equal to number, then we should set it to null. Otherwise, we should set that right there, okay? So, let's see. What's the number? What's the selected number key? 1, 2. It's still 2. 1. Clear doesn't change anything. When you click it again, though, it doesn't change, which is probably due to the use callback. So we need to add selected number key. Yeah, exactly. That's why it didn't change. Okay, cool. I think it's the same here. Selected square. It should do the same thing because, yeah, exactly. We are watching the selected square. So if you click selected square, here you can see selected square, and when you click it again, it should just unselect it. So let's see, 1, we click 1, then we click here. That should have changed. Interesting. So we click here again. Oh. Selected number key needs to be in the callback in order for this to trigger. So when you click here again, it deselects, and then you add it again, which is not the case that we want. That's not what we want. So if selected number key, grab the previous state. If previous state group index is not equal to selected number key, that's when you do all this. Cursor is not always perfect in the suggestions that it gives me, obviously. But if we do this means that we don't add the number again, right? which is good. So we need to do the same thing when we click another number. So if we click 2 here, you can see that the action was add a number to previous value 1 on this index. If we click 2 again now, it's going to not do what we want. Sorry, it's going to do what we want, but then the second time when we select the number again, we want to not add the same number to the same square again, which is on handle number click. Exactly. So here. Yeah. So number 2, we can't add that more than once. That's good. So now we can see that we've changed the value back and forth a little bit, which is great. So I think that should be enough for us to move on now. I think we should add the clear as well. So let's see, we cleared out. What happens? Let's make sure that happens. Remove the number. Clear again should not happen. So if we go over to handle clear click, selected square, if that is not equal to null, that's when we do this. So ensure that we only clear it once. Yep, nice. First we added the number 1 and then we removed the number. Previous value was 1, now the new value is null. That's pretty cool. We can see that action history still logs, obviously. So what we do next is probably validate the action that the user takes. So adding like a number to a square, that causes a validation change or a validation to be triggered. I think. So let's do another use effect. I want to keep the action history for a while, just to have that as a debug. Let's see, so we change. Yeah, maybe we shouldn't have that on the actual game state because the game state can change more than once. So what we want to do actually is when the action history changes, that's when we want to perform new validation. So that's when we want to trigger a validation of our game state. This should probably be populated into a different function, a different file, so we don't have everything in our app component. So let's create utils and then have game state, maybe, or convention formatting game state. Let's call it game state.ts. So the game state TS is going to handle stuff like validating the state. I think that should make sense. So let's export a function called validate game state. And I think this should take in action history, or should we simply, let's start by just validating the game state, and then we can look at maybe passing the game's the action history, or we can handle the action history in the app. We'll see. So let's see, we grab in the types, and I think it's, yeah, exactly. So let's see. Okay. We don't want to log. Interestingly enough, this is triggered. Now the game state changes as well. I don't like this. Mhm. It won't really matter if we validate it more than once, if we're completely honest, because the validation is the game state doesn't actually change that much. So, well, actually it changes obviously, but the changes are only going to occur actually once. So it's going to be the same value for whenever the game state is changed. Even if the trigger, like if we trigger this, we can see that the game state only changes once. Yeah, might as well do this. I'm sorry for forgetting. You have to have some oversight for the fact that I'm figuring this out as we go, but I guess that could be some at least a little bit entertaining or interesting. So now we know that the number 1 is in the first array, so we need to go over the whole game state and find out we should look at the action first, and then we can look at the generic state, I guess. Yeah. Because what I want to do is whenever the action is performed, we validate. And the action is the only thing that we care about in the validation. And whenever an action causes the state to be invalid, we don't want the state to be able to change. So you shouldn't be able to edit or put in any other number anywhere unless you go back and undo what you did that caused the issue or caused the error in the state. So we care about the previous history, like the action history. We care about that state. So validate game state should take the state as well as the action history. Since the history is empty in this case, we don't want to validate, but in the future when we have like an initial game state for some reason, maybe we want to make sure that the game state is actually valid from the get-go. But verify, let's say, just add a comment here, verify that the initial state is actually valid. Verify that we actually don't have to validate this game state when there are no actions. Okay, so from the get-go, we don't validate because the action history is empty. But if there's an action in the history, let's grab the newest action. So last action is equal to this. Let's look at last action. What is that? It is nothing currently. Let's go add number 1. It wasn't adding a number with a value of 1. And I think in the case of adding or removing, we don't really care, because if we add a number and it's wrong, we want to tell the user. If we remove a number whenever the state was wrong from the beginning, we want to tell the user as well if the change made the state correct, right? So we want to validate regardless of if being an add number or remove number. Okay, so we now know the new value, so that's what we care about. That's the number that we want to look vertically, horizontally, and within the square, right? So since we know the index of the group, we can go into the group and look, does this number occur in the square, right? So const is number equals the new value. And then we can check inside of the square, we have a group index, right? So group equals game state. Here's the group, right? So what we want to do is find if that number exists within that group, but we also don't want to care about the first instance of it, wherever we currently have it, right? So we might want to splice it from the index that this so last action square number index, and we delete 1, right? So this means that now we have, oh yeah, sorry. Let's do cost local state equals states. Let's do copy, so we don't actually destructively change things in the local state. So the local state grabs the game state and creates a new array from that. The group is a copy of the local states group, and then we remove that number, and then we can log the group. So now we can see that there are no other numbers within this group, right? Which is correct. So what we if group includes number, then return false. We can also return let's see, we have we don't want to return false or true, we want to return a message, I think. So let's look at types. Let's create a new type here called validation result, which contains which is an object that contains like is valid boolean and then an error message. I think that makes sense. String or null. Cool. So that's make sure that the function returns validation results, import validation results. In this case, we just return is valid true, error message. Actually, let's not say null, let's make that optional. So you can just return is valid true. Okay, so here, let's say is valid false, error message number always exists in group. Cool. So in that case, whenever there, so if the number contains more than once in the group, then return error message. If it doesn't, then we can go on and look at the other groups, right? So in this case, we have, let's say, number 1 in the top row and the leftmost column. So we only care about the numbers in index 0, 3, and 7 in all of the groups, except for the one that we currently are in. That's the vertical columns, and the horizontal row, it's only the numbers between 0, 1, and 2, essentially, right? So when we are looking at, we need to calculate we need to care about which ones, which numbers it is. So each row is 3 numbers. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, because the index starts at 0, obviously. And the column is 0, 3, and 7, 3 and 6, sorry. Yeah. So let's grab let's log. Let's say it's valid true here just for now, so that we don't have any errors. Stop. There we go. Let's say we want the last action. I want to see what the action is. Here's the action. We got the square, and what we care about the number index, right? So we have 0. Here we would have. Why doesn't it change? That should trigger a validation change, actually. It's because we don't change. Because we do change the game state. Huh. Or is it because... Is it for some other reason? Yeah. It's because we have the if statement, right? That's why it doesn't change. I'm fairly sure. Yeah. Validates. Okay. So that's fine. And it's because of action history is let's add the error message to the log in case it's invalid or something, or let's just log the validation result actually, just so we can see if something happens. You can see the valid is true, valid is false, valid number already exists. That's why we didn't get the log. That makes sense. We can remove this and then we should get the log. Number already exists. That shouldn't be true. I know what it is. Okay, so the number, well, actually, okay. Okay, interesting. So if the action is add number, then we should do the number. Interesting. Yeah. Validation depends on what we do, obviously. But if we add a number, let's say we add number 1 here, then we know that that square changes only within that number change. The only thing we need to validate is that square, this group square, and this row and this column. That's the only thing we care about. But when we remove a number, then it becomes the question of validating the whole game state. And that's not something we do currently. So the only thing that we do first of all in the validation is to check if there's an add number action going on. I think that's the only thing that we care about right now. Because if it's not a add number, because if we remove something, the state should not be negative, because we should lock the user from doing any more actions. So obviously this is going to take some time. This is only going to be the part 1 of the game, because it's taking a long time to do. But yeah, I didn't really intend for this to be a complete game. By the first video, it's going to take a while to validate everything, and I'm figuring this out as we go. So we're just going to finish this up, and we're going to call that a day for the video. So now we know within the group that we know if the number is valid. Otherwise, we're going to throw this error, right? So what we care about is the column. Yeah, exactly. So column and row. How do we figure out which row and which column we're in? We need to go ahead and grab which number this is. The column is going to differ between column 1, 2, and 3. So column 1 is indexes 0, 3, and 6. Column 2 is the indexes 1, 4, and 7, right? And then 2, 5, and 8, I guess. 8, 7, 6, 5, 4, 3, 2, 1, 0, right? So each column down here, we need to grab all these 2 columns and these 2 rows. That's what we care about. How do you calculate? We have to calculate the column, right? And how would you do that the fastest way, like the easiest way? Because otherwise it's a lot of if statements. The simplest way, I think, is to do columns to columns, where we have a list of each column, then do rows. I think this is correct. But no, wait. No, these are rows. These are columns. Each. Yeah, exactly. These are columns, those are rows. Yeah. So exactly. So now we can grab the row and the column. The number. Yep. In this case, yeah, that's 2. We can see that it is the column 2, 5, and 8, and the row 3, 4, and 5. Nice, that's cool. And let's go ahead and grab the other. What we care about is also the siblings vertical and horizontal and based on which group index it is, right? So I think it's the same thing here. Row 0, 1, 2. Yeah, exactly. So we can grab the group row, group column, and then we can grab the number row and number column. And exactly. So now we have the group row. So if we look at the group row and the group column compared to the number row and the number column, we can say, let's see, we put in number 1 here. We can see that the group row and the group column is going to be 0, 1, and 2, and then 0, 3, and 6. So these are the group. And then we have the same thing for rows, because if we go ahead and apply a number 2 here, we can see that the columns change, but the rows are the same for group and number, because you can see that the row is going to be this. The same thing goes with the group. It's these 3 groups. The group vertically as well, columns is the same, 0, 3, and 6. However, the column is going to be 1, 4, and 7 for the individual groups. So that's how we can look at these numbers and these indexes to validate whether this specific number exists within the group, within these groups' specific number indexes, right? Great. So now that we know that, we can go ahead and for each group row and group column, we also have to verify that we remove the group index from them, right? So we're going to find them, and then we're going to go ahead and do group row splice. group column. Yeah, exactly. So if group row and group column, I mean, they're never going to be null or undefined, but we might as well just validate them. Group row and group column, and number row and number column. We're going to go ahead and do group row splice group last action square group index. So we're going to remove the group from these individual ones, right? So now if we log that, we have number 1, you can see that the Y what? Is it logging the same thing again? No, it's not. That's number row. Oh, yeah. Oh, hold on. But what? It doesn't make sense, or does it? No, that doesn't make any sense. We're removing it from group row and group column. It's fine if they are empty from number 0, but these shouldn't change. But they do. What? What? Why? Why does it change? It's because we are referring to the same ones? Is that... Oh, it's a reference issue. Of course. We don't want to remove them there. Okay, cool. Now that we've done that, we can go through each group within this. For each group row, we can go through that and grab the number rows and go through the number rows to make sure that the number doesn't exist in those rows. So what you do is, let's do a for loop just because it's easier. For, let's do for cost row of or in group row sync row. So now we can just verify that when we click here, we're going to verify row number. Oh, yeah, for off. Yeah, row 1 and 2, thank you. So for each value in group row, that is the actual index, we want to grab that group. So let's do the same thing here. So group is equal to the local state group. There you go. Now you can see that the validation doesn't go through because you can see that the number already exists in that specific row, right? So let's remove these. Let's go ahead and number 1. And if we add it again here, you can see that it is number already exists in that row. Cool. And then we do the same thing for group column, right? Actually, this is not correct. It's not supposed to be in the group. It's actually supposed to be by the row, right? So now that we have the row group, we need to grab number row. So we need to go through each number row. So for const row number of row group, number row. We grab row group, row number, if row number is equal to number, and it contains in the actual row. And then we do the same thing here. Column number, we grab the column group and the column number equals the number, and we know that the number exists within that column. That should be it. So 1 exists here, and then we add it again. You see the number already exists in that group. Clear it out. Valid is true. We can add the number here. That shouldn't be right. Interesting. What am I missing? We click here, then I add number 1 here. Then we know that it's number 0 and 2 that we will validate. And the rows that we care about is maybe I should zoom this in. The rows that we care about are 3, 4, and 5. Yeah. So the numbers that we care about are these inside of the index 0 and index 2. It's 3, 4, and 5. 3, 4, and 5, right? So when we go through each row in group row, we're going to grab index 0 first. And let's just log here. Found duplicates in the, let's see, row in row. It's column. Okay, interesting, interesting. in number 1, 4? Why would you look in number 1, 4? That's my question. Oh, we remove. Yes, that is the issue. Okay. Now it's actually working. Ah, yeah, there we go. Nice. Okay, cool. So sorry. Yeah, that is the validation for whenever we add a number. Sorry if I got quiet for a while, off and on. That tends to happen when I think. But yeah, so now we can actually validate whenever a number actually occurs within the same row or column. That's pretty cool. So I think that should be enough for today's video. We've been doing this for a while now, so we're going to continue this as a little project. This is going to be part 1. I hope you found this a little bit entertaining at least, and that you could follow along. If not, then feel free to leave any comments for feedback below. I read every single comment of yours. I appreciate it so much for every comment you actually submit, and I also appreciate very much they actually watch the video. Really look forward to keep working on this little project because this was actually quite fun compared to what I usually build in my free time. So again, I appreciate you for watching, and I will see you in the next one.